Welcome to lesson 17. Let's try a second video and see how this one goes. Today we're going to talk about area of circles. And you notice what I have up here is a bunch of circles with the graph paper behind it. That's because area is the amount of square units inside of an object. For area of a circle, you notice the problem, and I'm circling this one right here, is that we can't get exact because of the fact that that circle has that continuous curve to it. Okay, all points equidistant from a given point. So this one looks like it has an area of 4 square units because of the fact that there are 4 boxes. However, some of the boxes are on the outside of that circle, so therefore it would be less than that. So we're going to talk about how to find the area. Next, what I'd really like you to do is find out the area of this rectangle below. All right, so it has a length of 6 centimeters and a width of 4 centimeters. So if you remember, the formula was A equals length times width. So area equals 6 centimeters times 4 centimeters. And just like lesson 16, I'm not going to worry about the labels now. We'll do that later. So when you multiply, you get 24 centimeters squared. But you guys should have gotten that. All right, but notice that there are 24 squares inside this object. If each one of these squares is a centimeter by centimeter, you would have 24 of them inside, so 24 centimeters squared. For number 2, it says to find the length of the rectangle if the area is 27 and the width is 3 centimeters. So area equals length times width. The area we know is now 27 equals length we don't know. So I'll just leave L as our variable. And the width is 3. So now we got to solve for L. Well, this is a simple one-step equation that we've done a lot of. You divide both sides by 3, and you get L equals 9. And this would just be 9 centimeters, okay? Because when you multiply centimeters times centimeters with length times width, that's where you get the centimeters squared for the area. Well, when you divide centimeters squared by centimeters, you get just centimeters, so the length is just 9 centimeters. We're going to apply this to something that we already know with circles. We're going to find the radius of the following circle whose circumference is 37 and 68 inches. And here it says to use pi is approximately 3.14. Therefore, find the radius. So we know yesterday from the lesson 16, I should say, that C equals 2 pi r. This is one of the formulas. Usually we say C equals pi d, but because of the fact that there are 2 radius or 2 radii and 1 diameter, we could say 2 pi r. So C equals, whoops, I did not mean to put that there because we know what C is. It's 37 and 68 equals 2. And instead of pi, we're going to put in the 3 and 14 times r. So this, in this case, we have to find out what r equals. So again, we're going to multiply the 2 times 3 and 14 to get 6 and 28 r equals 37 and 68 hundredths. To get r by itself, you divide 6 and 28 hundredths on both sides. So you get r equals, and you could use a calculator for this, I already did, and I get r equals 6. And in this case, it would be 6 inches because of the fact that we have to still put that label there. So the radius would equal 6 inches. But see, we can find out any variable as long as we know the other information. We just substitute it in for the ones that we know. Again, on number 4, same thing. We're going to find the diameter of a circle whose circumference is 15 and 7/10 centimeters, and pi is again 3 and 14 hundredths is what we're going to use. So in this case, we're going to use C equals pi d. Instead of using 2 pi r, we got to find the diameter, so we might as well use the formula with the diameter in it. So the circumference is 15 and 7/10. Again, substitute that in where we know. Pi is 3 and 14 hundredths. Substitute that in. And we don't know d. So it's just a simple one-step equation in this case, and that is to divide by 3 and 14 hundredths. And you get d equals, and again, you can use a calculator on this, but it would be 5 centimeters. Okay? So we're going to take this and start applying it to area and some of the more complicated problems. This is an exploratory challenge. What they did was they took half the circle. I'm going to cut this right here in half. Okay, this is half the circle up here, this is half the circle down here. And they cut it into all these little pieces. And then they did it like teeth down here, and they put those teeth together, and they created a rectangle. Okay? For the most part, we will say that's definitely a rectangle. Now notice that they did cut off a little bit of this tooth, cut it in half, and then they can put it over here. Okay, and I'll show you with that arrow there, all right, or bad looking arrow. But they put that other half over there, completing the whole entire rectangle. Well, we know that the area of the rectangle is length times width. Well, the length of this is half of the circumference, because the fact that this white here is the same as the white here, which is half of the circumference. So if the circumference equals 2 pi r, and we want half of that, we're going to take 2 pi r and multiply it by 1/2. Well, 1/2 times 2 is 1. So you just get pi r. So that's why they say half of the circumference there is equal to pi r. Okay, that's where you get that from. And then the width of this rectangle is the radius. So that's why they have the radius right there. Well, as we know, area equals pi r squared. So therefore, area of a rectangle equals length times width. So the area equals length, pi times r, times the width, which is r. And when you have r times r, we're just going to put it down as area equals pi r squared. Okay? And this stuff here, the circumference is 2 pi r, the radius is r, therefore half of the circumference is pi r, that's what I showed you up above there. And then what is the area of the rectangle? Using the side lengths, area equals pi r times r, or area equals pi r squared for a circle. Are the areas of the rectangle and the circle the same? Yes. Okay, because as you can see, they work out there. Now you could go and talk about the fact that there's little curves on those and so on, but for the most part they are the same. So therefore the area of a circle is equal to pi r squared. Now I have another video, and we're going to see how this comes through. All right, another video in queue that will kind of show you this as well. So please listen to this.
Let's also review. Multiplying a number or variable by itself is known as squaring it. So for example, 9 times 9 is equal to 9 squared, which is 81. Remember, squaring a number means using the exponent too. Or r times r is equal to r squared. Let's take a look at a common mistake. Remember the order of operations. Exponents come before multiplication. If I'm simplifying area equals 3 1400 times 4 squared, if I'm incorrectly using the order of operations, then I may first do the multiplication and get area equals 12 5600 squared, and then incorrectly get that area is equal to 157 and 7,536 10,000ths. When I know the correct way to simplify it would be first to do the exponents. So I would get area equals 3 1400 times 16, and then multiply. So I would get area equals 50 and 2400. Let's take a look at area of a circle. A pizza has a radius of 9 inches. What is the area of the pizza? Well, let's visualize our pizza. It's going to be in the shape of a circle. I know it has a radius equal to 9 inches, and I know radius is the distance from the center to the edge. So let's take a look at how this pizza can help us find area. Let's start by dividing our pizza into slices. To do that, we're going to take different diameters across the pizza, and now we've divided it into 8 slices. And now let's take those slices and rearrange them so that they're in a more rectangular shape. Here I've alternated the slices, so now I have a shape closer to a rectangle than to a circle. And let's think about what the dimensions of this rectangle would be. Well, I would have my radius represented, and I would also have the circumference represented. And because I've alternated the wedges, notice that I have half the circumference for one length, and then the other half of the circumference for the other length. So I can say the length is equal to pi times the radius, because circumference is equal to 2 times pi times the radius. And I can see the width of the circle would be equal to the radius. So that I can use that to...
Now, one quick thing, what they just are talking about here, if you notice this section here that I'll draw in, if I took this and put it over here, it would do this here, making it more of a rectangular shape. It's just that they cut it down into 8 pieces where the other one had cut it into more pieces from your notes.
Help me find area. Well, in a rectangle, area is equal to length times width. And so I can say area of a circle is equal to pi times radius squared, because I multiplied the length of the rectangle made from the circle times the width of the rectangle made from the circle. And r times r is r squared. So now let's take a look at finding area of a circle. Well, we have our formula that we're going to use. Area is equal to pi times r squared. And since the radius of our pizza was 9 inches, we plug that in. And we use order of operations, which tells us exponents before multiplication. So we get area equals 3 1400 times 81 inches squared. I'm using an approximation of pi, since that makes sense for a pizza. And now I'm going to multiply 3 1400 times 81 inches squared and find that the area of the pizza is 254 34 inches squared.
Okay, so one thing I wanted to point out, this is that Learn Zillion. So you could go to learnzillion.com, okay, and look at that for your other things. If you want other videos and stuff, they have a bunch of videos. They have practice work and so on and so forth. So that might be something beneficial to you. Now, back to this. So we got area equals pi r squared. Go to the next page, and it talks about a sprinkler. Well, if you think about a sprinkler, you got the sprinkler system right here, and it shoots out water. The water goes over a distance of 12 feet. So this would be 12 feet. And then the sprinkler system goes around the whole entire area there. So with this 12 feet is really the radius equals 12 feet. Okay, that would be the radius. So it says, what is the area of the circular region covered by the sprinkler? And it says, find it to the nearest square foot. Okay, well, the distance of the 12 feet represents the radius. And what information is needed? We need to know area equals pi times radius squared, the area formula. So area equals pi times 12 squared. Now it's 12 feet, but we'll put that in at the end. So area equals, now they just said you have to do exponents first. So 12 times 12 is 144 times pi. This would be the exact answer, all right? And it would be feet squared. But 144 pi feet squared would be the exact answer. However, they want us to round it to the nearest square foot. So what we'll do is either use the calculate button or the 3 1400ths to plug in pi as 3 1400ths or the calculator button. Either way, you get 452.3. Now, 3 with some other numbers afterwards, obviously. But either way, that tells us to round this 452 3/10 to 452 feet squared. So that sprinkler covers about 452 square feet of your lawn when you're using the sprinkler. Okay, now we'll go ahead and take a look at exercise 1 through 3 and do those real quickly. I know this video is a little bit longer, I apologize, but I wanted to show you that other video with Learn Zillion, and maybe you guys will use those as well. So a circle has a radius of 2 centimeters. Find the exact area. So area equals pi r squared, and we know the radius is 2. So area equals pi times 2 squared. 2 squared means 2 times 2, which is 4. So area equals 4 pi, and this would be centimeters squared. That's it. That's the exact answer. Now, this says find the approximate area using 3 1400ths as pi. So area equals pi times 2 squared. But in this case, we're going to put area equals 3 and 1400ths times 2 squared. 2 squared is 4. 4 times 3 and 1400ths, area would equal 12 and 5600ths centimeters squared. That fit in there, sorry. Okay, so that's number 1, another example of it. I'm going to have you guys do number 2, where the radius is 7 centimeters. The only thing really big difference on this is 22/7 instead of 3 and 1400ths. So keep that in mind. And then last but not least, you guys will find the exact circumference and find out the approximate circumference of that as well. Now the last one that I wanted to go over is Joanne and Melinda here, who have a disagreement. Joanne said that the area was 400 pi centimeters squared. Melinda says that she is wrong, is incorrect, and she says the area is 100 pi centimeters squared. So who is correct and why? So what I'm going to do on this is just look at what we have. This right here represents the what? Hopefully you said diameter. So if the diameter equals 20 centimeters, we need to know the radius, because our formula is area equals pi r squared. That does not mean diameter. Remember, radius squared means radius times radius, not radius times 2. So hopefully you already figured out that radius of this would be 10 centimeters, because it's half of it. So when we substitute that in, we get area equals pi times 10 squared. Now notice both of their answers were in pi. They were exact answers. So I don't have to replace the pi in this one. So I do have to go and say, what's 10 squared? 10 squared means 10 times 10, which is 100 pi centimeters squared. So therefore, Melinda is correct. And just FYI, the reason why Joanne is wrong, if you take 20 and square, you get 20 times 20, which is 400. So she did diameter squared to get to 400 pi. It should be radius squared, which is 10. 10 squared is 100 pi. So therefore, Melinda was correct. All right? And that concludes the second video. Thank you.